and McCoy, R. McCoy. We're out here on a rainy Friday. Everything's a little wet. Wanted to talk about what we were doing today and how important it is to contractors, suppliers, and pumpers. But what you can see going on behind me right now is actually a mock pour. And it's in conjunction with a trial batch for Parkview Regional Medical Center that will start pouring in about a month as we start going vertical. Now what's important about this mix and why it's necessary for us to have a trial batch, have a mock setup pour to simulate actual conditions, is we're going to be using a lightweight concrete, which is important in structural design. It decreases dead load, it does all those nice things we talk about for the keywords of sustainability, reliability, all this stuff in engineering. And one of the differences, you're thinking, well, why is he holding these two things? Well, what I wanted to talk to you about was the difference in normal concrete as opposed to lightweight concrete. So the unit weight with this concrete is right around 117, 118 pounds per cubic foot. Why does that matter? Normal concrete, everyday concrete, is about 145 pounds per cubic foot. So it's lighter. How do we make it lighter? Instead of using a normal aggregate, this represents our normal aggregate, we use a lightweight aggregate. So think baseball, wiffle ball. So that aggregate, in this specific mix, it's Hydrate. What you end up with is more surface area because it's taking up the same amount of volume. It just has less mass and it's more porous. So in a normal mix, the water's on the outside. Yes, the aggregate does hold some inherent moisture, and that's taken account of in the mix. But with lightweight aggregate, what you have is a situation like this. And why it's imperative to get your mixing properties right on a test batch and a mock pour is so that you don't end up with a disaster in real life. So it's important to coordinate with your contractor, your material supplier, to go to pre-pour meetings, to discuss with the contractor and the supplier what are your expectations. Here's what we can do as a concrete company. So with this lightweight aggregate, it's very important to monitor the moisture content. This needs to be saturated. As you can see, when it goes through the concrete pump, if you don't have it saturated, it has room to absorb moisture. So what does it do in a concrete pump? It gets compressed. There's pressure in there. And what that does is it forces the water into the lightweight aggregate. What does that do from the hopper to the point of placement? Dries it out. So then you end up with issues like plugging, right? So we like that cementitious material. That's what really helps us get the concrete flowing. Is all that cementitious material. When you end up with too much aggregate and not enough cementitious material, which is what can happen if most of your water and paste starts to really coat to this lightweight aggregate, those are the problems you're going to encounter. So it's very important on lightweight concrete pours for workability and pumpability, which are two things that are considered the same but are somewhat exclusive of one another. A lot of people attest to, as you can see, a slump to workability. But workability and slump doesn't necessarily coincide with pumpability. So you can have a 9-10 inch slump that's chemically induced, and what that chemical does is a high range water reducer. And I'm going to notice and throw back to Dr. Tyler Ley and Dr. Jason Weiss. Those guys have some great stuff on smaller lightweight aggregate for both internally cured concrete and dealing with different aggregate proportions in Dr. Ley's perspective. Very good stuff. You guys should take a look at that if you're interested in learning more about individual concrete mix design and aggregate segregation. So the problem you run into if you don't have this saturated, like we said, the pressure pushes that water into this once it goes through the pump, and you get a really dry mix coming out. The other problem is, such as on a day like today, you've got this saturated from the day before, you get 2 inches of rain overnight, and now we're super saturated. So the same thing can happen. It goes through the pressure, and excess water, just as you get with this, can come off of that aggregate. So you have to adjust your water content in your mix design constantly. When I say constantly, I mean on a daily basis. you need to know what your material properties are for a mixed design that needs to be pumped that has this kind of intentions. You know, we're pouring multi-stories. This is going to go up to a 7-story building. Nobody wants to rip out a deck because we've got the wrong mix. So it's important to get it right. And one of the other things I wanted to talk about that a lot of contractors don't understand, and what a lot of suppliers don't understand, is workability and pumpability and how they're different when comparing slump. So in this particular pour, the specs call for about an 8-inch slump. So what you'll find is if this is improperly saturated, you're sucking water out of the mix, and normally an inch of slump you can lose about 10 pounds of water. So right around a gallon, a little over a gallon of water per inch of slump. So if that's coming out of the mix, it affects the workability on the end. So now let's talk a little bit about high-range water reducers and how it affects cement. And again, Dr. Tyler Ley is a great source on this. He explains it way better than I could. But you have cement particles with nothing in it. They have a tendency to froth together. So when you have locking taking place, they tend to join. Concrete finishers don't like that. They want that workability. So you either add more water, which is detrimental to strength, and there's a lot of other inherent properties about adding water to concrete that are not good in the long run. So they come up with this water reducing agent. So what that does is we've got basically 2 charges here. It coats the cement particle and places a negative charge, a net negative charge on this cement particle, and a negative charge on this cement particle. It naturally makes them separate instead of locking together. So what you get is a nice consistency, workability. Now, fictitiously, you would think, well, it should pump better, but it really doesn't, because what really helps us pump is the cement paste and the water used, right? That's what coats the pipe, lines the system, especially in this pour where I think we've got 150 foot of system. Now, as you contractors know, that's real life terms. But as pumpers, what we think about is what's the makeup of the system. For example, for every foot of rubber hose, that equates to about 3 foot of steel pipe. So if you go back, and I don't know if any of you have had hydraulics class or dealt with piping systems at all, you deal with things called minor losses. And what those minor losses correlate to, in the end, all involve taking stuff out of the mixture as it travels along that path. So what we're trying to meet here with a mock pour and a trial batch is that perfect setup. Where does the light aggregate need to be? Where does the normal aggregate need to be? What other mixtures need to be right? What water content needs to be used for the specific gravity of the aggregate? All that comes together when you start looking at things like pumpability, workability, and optimally the strength the engineers want to get out of it. I hope you've enjoyed looking at what a mock pour does and what a trial batch looks like. Sometimes things go great, sometimes they go wrong. That's the whole point of running tests. I'd rather it go wrong here than out on the job. Thanks.